You know, for the first time in human history, we are right on the edge of giving every single person on Earth high-speed internet. I mean, it's a total revolution. And it's all being powered by tens of thousands of new satellites. But, and this is a big but, this incredible achievement comes with a hidden cost, one that's changing our relationship with the sky itself forever. Let's break down what's really going on.
This sentence right here, it just nails the core of the issue, doesn't it? On one here, you have this huge leap forward for the whole world. On the other, you've got this new profound problem that could be irreversible, not just for science, but for all of us.
Okay, to really get a sense of the scale of what's happening, look at this number, 10,000. That's roughly how many satellites humanity launched in total, from the very dawn of the space age with Sputnik in 1957, all the way up until just a few years ago. Now, hold that number in your head and compare it to this. Over 100,000. That's how many satellites private companies are planning to launch in just the next decade. We're not talking about a small increase here. We're going from a few thousand objects to over 100,000. This is a complete and total transformation of the space around our planet.
So you gotta ask, what is driving this insane race to space?
Well, it all comes down to these things called mega-constellations and the unique real estate in a very specific region just above our heads.
Yeah, we're not talking about just a handful of satellites anymore. Think of a mega-constellation as a vast interconnected swarm of devices all working together, blanketing the entire planet in a web of internet connectivity.
And they are all fighting for a spot in what's called low Earth orbit, or LEO for short. So why there? Because being that close to Earth means incredibly low latency. We're talking internet speeds that feel just like the fiber optics you'd get at home. Plus, you get total global coverage. So LEO has basically become the prime real estate of the 21st century. And here's the catch. There's only so much of it to go around. Now, this new digital blanket is an absolute miracle for people on the ground needing a connection. But for the people looking up, for astronomers, it's quickly becoming a total nightmare. Let's look at the most immediate impact. It's literally blinding our view of the universe. This really paints the picture, doesn't it? For thousands of years, our view of the night sky was this pristine black canvas, filled with these faint whispers from distant galaxies. But that view is being replaced by what some are calling a digital veil, a sky filled with bright man-made streaks and a constant hum of signal noise. So, this hits astronomy in two huge ways. First, visually. These super reflective satellites are like celestial photobombers. They streak across long exposure images, ruining the data we need to discover new galaxies or spot asteroids that could be a danger to Earth. But for radio astronomers, it's way, way worse. The signals from these satellites are millions of times stronger than the faint signals from space. It's like trying to hear a pin drop while someone is screaming right into your ear. But okay, ruined photos are one thing. The threat here goes so much deeper than that. As low Earth orbit gets more and more crowded, the physical danger to everything in space, and maybe even to us on the ground, is just growing exponentially. And this brings us to this really scary idea, something a NASA scientist named Donald Kessler warned us about way back in 1978. It's called the Kessler Syndrome. The idea is that once orbit gets crowded enough, a single collision can create a cloud of debris, which then causes more collisions, which creates more debris, until you have this runaway chain reaction that makes that entire orbit totally unusable for centuries. And here's what makes that so terrifying. We're not talking about slow-moving junk floating around. At orbital speeds, even a tiny piece of debris, something the size of a marble, hits with the kinetic energy of a bowling ball dropped from a skyscraper. So a dead satellite isn't just garbage, it's a high-speed, ticking time bomb. But what about the satellites that don't fail? What about the ones that work perfectly? Well, the plan is to have them just burn up in the atmosphere when they die. For years, we thought of this as a clean way to get rid of them. But now, at this massive new scale, we're realizing it's a huge problem. All that vaporized aluminum from tens of thousands of satellites is creating a permanent cloud of metal dust high up in the stratosphere. And scientists are worried it could start to damage our planet's protective ozone layer. Okay, so with all these enormous risks, you have to be asking yourself, who's in charge here? Who's policing all this? Well, the scary answer is nobody, really. Our space laws were written for a totally different time, and they are completely unprepared for what's happening right now. Get this. The most important law we have for space is the Outer Space Treaty. It was signed in 1967. It was designed for a world where only big countries like the US and the Soviet Union went to space. It says absolutely nothing about a future where private companies launch satellites by the thousands. We are living in an orbital Wild West. There's no global zoning board for orbit that can say, hey, that's enough. Here in the US, the FCC gives out licenses, but they're not required to study the environmental or visual impact. And efforts to fix things like painting satellites black to make them less reflective are completely voluntary. We're basically just relying on the goodwill of billionaires to protect a global commons that belongs to every single one of us, erasing a night sky that has been a source of wonder and meaning for all of human history. So I know, the situation seems pretty dire, but it's not totally hopeless. The goal isn't to stop progress, of course not. It's about finding a way to make this whole endeavor sustainable. So what can we actually do about it? Well, the good news is, for every problem we've talked about, there are potential solutions on the table. We can make rules that require satellites to be darker and less reflective. We can create radio quiet zones on Earth where astronomers can listen without interference. We can and should develop tech to actively clean up dangerous space junk. And we can start treating the night sky like the precious global heritage site that it really is. Which really leaves us with this one final question. Connecting the entire planet is one of the great humanitarian goals of our lifetime. There's no question. But in our rush to build that global web, we are fundamentally changing a part of nature that has inspired humanity for millennia. So, have we traded the stars for the web, or is there a way that we can have both?